If you want to learn the basics of Tinkercad, keep watching. For a few simplified examples of splitting and combining objects, jump to this section. If you are already familiar with Tinkercad, jump straight to the STL modifications section. If you find this video helpful, jump to my Patreon page and become a Patreon. Subscribe to the channel and check the video description to find out about other ways you can support my efforts. Enough jumping, let's start with the basics. Tinkercad is one of the simplest tools that you can use for manipulating existing STL files of 3D designs you find online. Visit the website and sign up or log in. When you want to create a part, add something to an existing design, or even fill a gap, you draw a solid object. There are many different shapes you can choose from, but to keep things simple you can just use the cube. You can place it wherever you want on the work plane, and adjust its size by clicking and moving on its corners and edges. Hold the Shift key on your keyboard while adjusting, and it will change all the dimensions at once. Use the left key on your mouse to select or move something. Use the right key to rotate the view. Use the middle key to move around the work plane. To undo a change you made, click the Undo button or press Ctrl-Z on your keyboard. You can also input the exact dimensions you want for an object by changing the values for length, width and height. When you want to remove something from an existing design, or split it in multiple parts, you draw a whole object. From the default shapes you can choose a whole cube or a whole cylinder. You can also convert any solid object to a whole, whatever shape it has. The dimensions of the whole object and its position on the work plane are adjusted the exact same way. It may help you visualize your design better if you choose a different color for each object you create. In order to combine two objects, select the two solids, either by clicking and dragging your selection over them, or by holding down the Shift key and clicking on each of the objects. You can then click on the Group button, which will combine the selected objects into one. If you need to place an object on top, next or under another object, you can reposition your work plane by clicking on the surface of the object. This way the new object is drawn on that new work plane, touching the surface of the first object. To subtract one object from another, you need to combine a solid and a whole. Same as before, select both objects and group them. The portion of the whole that intersects with the solid will be removed. You can ungroup a selection at any time, revealing the objects that were combined. The work plane position is a very important and helpful tool in Tinkercad. By repositioning the work plane you can easily draw holes and remove specific parts that protrude from an object. Just make sure that the whole object completely covers the piece you want to remove. You can make duplicates of an object by selecting it and clicking on the Duplicate button. If you are going to move the duplicated object anyway, you can hold Alt key and drag the object. You will be moving the duplicate and the original object will not move. You can also copy and paste the object, using Ctrl-C and Ctrl-V on your keyboard. Changing the snap grid to a smaller increment helps with moving objects more accurately. I am always working with 0.1 mm. Don't forget to rename your project so that it makes sense after a few weeks. These basics will be enough for what you need to do next. Thanks to PCBWay for sponsoring this video. PCBWay is a one-stop shop for your PCB prototyping. Create your own standard, advanced and flex rigid PCBs. Order a completely finished board with their assembly service, or even let them design it for you from scratch. PCBs start from $5 for 10 pieces. Register now for a $5 welcome bonus and pay only for shipping. Check the links in the video description. If you have an idea, step up from the messy prototyping breadboards and bring it to life on a full-fledged PCB made by PCBWay. Now, let's split and combine some objects. Let's make a very simplified example of a GoPro camera mount. Create the bottom and sides of the base by combining rectangular shapes. Hold Shift on your keyboard when moving the objects to move them in a straight line. Reposition the work plane to create whole objects and shape the base as you please. Selecting and grouping multiple holes and solids will result in just one single object. For the sake of keeping things simple, create a box and imagine that it is the camera housing. Don't worry, more detailed examples on actual STL designs will follow later in this video. Select the housing and the base and click on the alignment button. Click on the base once, if you want to align the housing according to the position of the base. Select the housing part and click on the curved arrow to rotate it, imitating a camera angle of 25 degrees in this example. Position the housing on the base. You can click on the top or bottom arrows to lower the object into place. Then combine all the parts to get one single object. Let's make another simplified camera mount, starting with a wedge shape. You can create a whole rectangle, align it with the center of the wedge shape and combine the two parts. This way you don't have to create the bottom part and side parts of the base separately. The top surface of the wedge shape is already at an angle. Instead of creating the camera housing and rotating it later to match the angle of the base, you can reposition your work plane and create the new part already at an angle. Position the housing wherever you want on the base and remove the remaining part from the back of the camera mount. In most 3D design software, you can revert back to previous instances of your design. In Tinkercad, for example, you can always ungroup the parts of your objects. But let's see how you can split an object that has been designed by someone else, and all you have is their final 3D design. Start by duplicating the object. Reposition the work plane to where you want the split to happen. Create two whole objects, one in each direction. Make sure they completely cover the original solid object. Select one of the whole objects and click on the Hide button. This will temporarily hide the selected object, so you can click on the objects inside it. Select one of the duplicated objects and the other whole and combine them. In this example, you essentially remove the base of the mount. Now press the Show All button to reveal the hidden parts. Select the other duplicate object and the remaining whole object and combine them. You remove the housing of the mount, so what you end up with are two parts of your original object, the housing part and the mount part. Let's split the other example into three parts. One way to do it is step by step. First, split the housing from the base by repositioning the work plane and create whole objects that cover your parts completely. Then split the base in two separate parts, following the exact same procedure. A more complicated but very useful way of doing such a split is by shaping a hole to match the parts you want to be split. Same as before, adjust the position of your work plane and create a whole object. Reposition your work plane and create a new whole object, which will be used to reshape the first one. Make the first hole into a solid and combine it with the last hole. The solid will now be shaped in a way that matches the bottom surface of the camera housing and the top part of the mount. Then convert the new shape into a whole object. This method is also very helpful when you want to clean up a part. More on that later. You will need two more whole objects to cover the rest of your parts. One for the camera housing and one for the bottom of the base. The rest of the procedure is the same as before, just with more parts. To split the object into three parts, you will need duplicates of the original object and duplicates of the whole objects. Select the holes in pairs and combine them with each duplicate instance of the object. In this example, hide the bottom hole. Select the other two holes and combine them with the object. Reveal the holes. Select a different pair and combine with the duplicate object. And repeat the same for the last pair of whole objects. In each of these steps, You are essentially removing the parts that surround each of the split parts you want to end up with. Now that you have split the original objects into the parts you need, you can move them around, align them with other parts and combine them into a new and completely custom part. This way you can modify an existing design in a matter of minutes. I will show you a few examples with GoPro and Insta360 mounts to see how easily you can adapt any camera mount to any frame you want. This is of course not limited only to camera mounts. You can do almost anything you want with a free and easy tool like Tinkercad. The position of your work plane helps you do a lot of complicated things easily. In this example, let's see how you can remove the rear part of the base, but only its middle section. Move the work plane to the back of the camera housing and create a rectangle. Now, instead of trying to align your shape to the sides of the base, you can let the work plane do the work for you. Place the work plane on one side of the base, create your whole shape and extend it away. Do the same for the other side. These two whole objects can now be removed from your rectangle. Then you can convert it to a whole object and use it to remove the part you need from the design. You can also add a hole to the design by creating hole cylinders. Adjust the diameter and its exact position. Make sure it goes through both sides of your part and combine them to create the hole. I think you are now ready for some real examples. Here is how you can modify existing STL files, designed by others. Let's import a GoPro mount for a Taycan, a GoPro mount for an Apex frame and an adapter for Whoops. I found these on Thingiverse. Check the links below to experiment with the same parts on your own. We will modify these designs to fit the GoPro mount of the Taycan onto the Apex frame. We will also modify the Whoop adapter and create a GoPro mount for a Whoop mounting pattern. Here is what the Whoop GoPro mount looks like when printed. Start by removing the parts that protrude from the original design of the Taycan mount. Move your work plane, create your whole object, adjust its size and combine. The back of the mount does not look clean, but it is very easy to fix it. Create a shape over the smooth curve which you want to apply to the rest of the part. Duplicate the camera mount and convert it into a whole object. Subtract the whole object from the small shape you designed. Then grab and extend its side so that it covers the back of the mount completely. Make this solid into a whole object and combine with the original design. The back of the mount is now clean. The same idea applies to the Apex mount, but with a few extra steps. If you just create a whole object that covers the camera housing, the bottom edge of the whole object will extend into the base. This means that it will remove part of the base together with the housing. To avoid this, you will shape the whole object so that it does not extend into the base. You know the drill. Work plane, whole object, combine, and you are done. Now that you are left with the base of the camera mount, you will need to clean it up as well. Keep it simple and clean bit by bit. There is no need to overcomplicate things. Let's deal with the Whoop adapter now. What we need to do first is fill the gaps, to make it more sturdy and to create a surface on top of which we can add the GoPro mount. Your shape may extend into the mounting holes in the corners, but you now know how to deal with this. Create hole cylinders and place them over the mounting holes, one for each corner. Remove these cylinders from your center piece and cut it to the desired height. Then you can remove the mounting holes that extend from the sides. Set the position of the work plane, cover the part with a whole object, select all and combine. If you don't like the notches that remained on the edges, fill them with solid objects. Create a larger solid and modify its size with whole objects. Combine everything and you are done. Let's combine the parts now, and make our custom designs. Make a duplicate of the Take-In GoPro mount and remove its base completely. You will be using the base of the apex mount, so you won't need it. Position the camera housing on the apex mount and align them so that they are centered. Rotate the camera housing to match the camera angle of the apex mount. Align and reposition until the base and the housing are touching on all sides. You can convert the housing part into a hole so that you can look through it and see when it overlaps with the base as you move it around. When you are done, select both parts and combine them into one. For the GoPro mount with the Whoop mounting pattern, we will use the Take-In mount, including its base. Move it onto the Whoop base you created. Trim its sides to make it more narrow. This will reduce its weight and also let you reach the mounting holes more easily. You can also trim the bottom corners of the mount by using a different shape. In this example, I am creating a roof shape and converting it into a hole object. I duplicate and reposition it on the other side. Then I select the holes in the camera mount and combine them. Combine the mount and the Whoop base to get your final design. Removing unnecessary material reduces the weight of the part. It also reduces printing time. Exactly how much material you remove will depend on your application and experience. You can strategically remove parts from your design, without affecting its durability much. But be careful. Removing parts and creating holes on multiple sections of your design will also affect how easy or difficult it will be to actually 3D print the part you are designing. This is where experience kicks in, and it is something you will gain over time, through a lot of failures and plenty of successes. Tinkercad also lets you create text. This way you can quickly and easily add your name on the part you designed. Depending on the part and how you are planning to print it, you may have the text embossed on the part, engraved into the part, or go completely through it. Here is an example for a hole shaped as text. Choose the position of your work plane, create your text, and adjust its size. Position the text so that it goes through the other side of the part and convert it into a hole. Combine the whole text and the solid design. Then inspect the design and make sure you remove all the remaining pieces that are floating, so that your printer does not try to print them in mid-air. Do I really have to create a 3D text in Tinkercad to convince you to subscribe to my channel? What are you waiting for? Subscribe and consider supporting the channel. You can find out more in the description below. Thank you in advance. Back to learning. Let's assume you cannot find any existing design that matches your mounting pattern. In this case, you will have to measure the mounting holes and design a base on your own. Create a hole cylinder and duplicate it. You need to have one cylinder for each mounting hole of your part. Move the side slider to the far right for maximum smoothness of the holes. Let's say that the front holes of the frame are 27 mm apart. You will select one of the cylinders and move it. Hold Shift while moving, so it moves in a straight line. The work plane grid is in 1 mm increments. Moving the cylinder by a value of 1 will move it by 1 mm to the direction you selected. Select a whole cylinder and move it 27 mm away from the rest. The rear holes are 24 mm apart. Select another cylinder and move it by 24 mm to the same direction. From front to rear, the distance of the holes of the frame is 32 mm. So select the cylinders that are spaced 24 mm apart and move them to the back by 32 mm. Now you need to align the holes. Group the front cylinders together and then make a separate group for the rear cylinders. You will end up with two groups. Select them both and align to center the centers of the groups. Now you should have holes that match the mounting pattern of your frame. Make them into one group and continue to the base design. Start with a basic shape to fill the area between the mounting holes. Add a solid cylinder around each hole, to have enough material around the screws. You can always ungroup the holes you made earlier and align the solid cylinders to each hole. You can also move two solid cylinders apart with the same distance as the holes. Group them and align the two groups. This will give you the same result. Adjust the height to match the height of the rest of the base. Now create hole objects along the edges of your basic shape, which will be used to form its final shape. In this example, I am placing and aligning a few oval shapes on the edges of the base, between the mounting holes. When you are done, select all the solids and holes you created and group them. What you get is one single object, with the holes and shape you want. Here is a more curvy example for you. The goal is to convert this mount for an Insta360 camera to a dual mount version, so that it is mounted vertically or horizontally. Here is the end result in Tinkercad. And here it is after I 3D printed it. Works like a charm and fits like a glove. First we need to isolate the mounting piece from the rest of the design. Shape a hole object to match the part you want to get from the existing STL design. Create an object that covers the rest of the part and subtract the first hole from it. This way you can split the design exactly where you want. You are now left with the mounting piece and the rest of the camera housing. Duplicate the mounting piece, rotate it and move it to the side of the housing. Position it exactly where you want. You can align it, move it with your mouse, or use the arrow keys on your keyboard to move it in small increments. Duplicate the housing design and convert it into a hole object. Subtract it from the mounting piece by combining the whole housing and the solid mount. Clean the remaining unnecessary pieces by creating hole objects that cover each piece you need to remove. Keep it simple and work step by step, piece by piece. If we wanted more complicated and powerful stuff, we would be in Fusion 360 or Mesh Mixer right now. Reveal the hidden part of the design and check all around the part. Make sure that your part does not have protrusions in places you don't want. For example, from the inside walls of the Insta360 mount. This may create problems when you try to fit your camera into the mount. Combine all the parts and export as a new STL file. Open it with your slicer software. Choose the appropriate profile and settings and send it to your 3D printer. Enjoy your new, modified, custom 3D print. Now use the skills you learned in this video to split, mix and match any design you find online and create your own version of it. Remember to give credit to the original designer and share your remake with others. 3D printing is a great hobby and has a massive community behind it. You never know how many people can find your modified design useful. If you found this video helpful, let me know in the comments below. I have been meaning to do this guide for a long time, and I hope it gave you all the necessary knowledge. Consider supporting my efforts if you feel like it. You can join my Patreon, tip me on PayPal and use my bookmarks that are linked in the description, so you can support me when you make purchases without costing anything to you. Thank you.
See how you've grown while you roam in the streets all alone. Thinking about what your life came to be. You're a beautiful sight.